Okay. You were talking about delayed reproductive maturation as it related to the fruit flies who you said you didn't let lay the eggs or delayed them laying the eggs. Is that correct?
Actually, they reproductively mature just a day or so later. They then have sex week after week after week. They're partying it up just like you do in Florida. Uh, but they don't actually produce children until much later because that's when I let them, or my graduate students let them, biologically reproduce.
So you delay the reproduction, but not the ability to reproduce.
Or even the recreational activity, just as, you know, we do with graduate students and medical students and medical residents and postdocs. Yeah, they can have all the sex they want, and they do, but the actual production of offspring happens later. So in other words, it is not an effect of avoiding sex as a recreational activity.
I recall a presentation you made at a conference about 8, 9 years ago. You talked about the salmon who would swim upstream to reproduce, the male salmon, and then they would die right after they reproduced. Whereas the salmon who just swam in the Pacific Ocean for a long time, they lived maybe 6, 7 years. And what it was is they were essentially, I guess, delaying having sex, but it was not related to delayed reproductive maturity, is what you're saying. It's just that their very act of engaging in sex upstream is what caused them to acutely die.
So there's a lot to be said about that, Bill, and that's a really good question. Uh, so the simultaneity of sex and death in that species occurs because uh, evolution by natural selection has tuned their life cycle so that when they are swimming upstream, natural selection directs them first to put all their resources into successfully swimming upstream, which is very challenging. And then with whatever they have left, it all goes into producing gametes, shedding those gametes in the water of their streams along with dozens and dozens of other salmon. And once they've done that, their probability of being able to go back out to sea and come back again is effectively zero. So their bodies undergo one of the most rapid processes of animal aging we know of in the living world. An interesting contrast is with Atlantic salmon, which are now extinct in the wild, in which they don't have the ascent geographically from the ocean to their natal streams, if they didn't, and of Pacific salmon. So it was fairly easy for them to go to the natal stream, squirt out their gametes, go back out to the ocean and back and forth. And the Atlantic salmon exhibits no such pattern.
Very interesting.
The Atlantic salmon can reproduce over and over again. There are actually many insects that are analogous to the Pacific salmon, the most famous of which are the mayflies that emerge as adults without any mouth parts. They'll never feed as adults. All they'll do is fly around looking for that, significant other with whom they, have a brief copulation. And after they've done that over the course of a day or 2 days, they're all dead. Okay? So natural selection at one end of the spectrum can produce a very extreme aging process that does in fact kill virtually every individual in the population once they've entered the reproductive window. But the vast majority of species are like humans in that we have multiple opportunities to reproduce. So, while Jimi Hendrix approximated the Pacific salmon and had a spectacular 3 to 4 years of frequent copulation, interspersed with rock concerts, and died thanks to his lifestyle. Most humans do not live that way. Most humans, don't have hundreds of mating opportunities over the course of a few years or thousands. And instead, we stretch it out. It all gets stretched out. And in fact, it stretches out to such an extent that um, some of us will live long enough to enter the post-aging phase.
Very interesting. One of our researchers has sent me a tremendous amount of material that he's written up on the potential virtues of humans delaying reproductive maturity using drugs like Lupron, which suppresses the release of luteinizing hormone from the pituitary gland, and that essentially delays puberty. And his argument, and it echoes a lot of what you're saying, is that if young people chose to delay reproductive maturity, literally delay their onset of puberty, that they theoretically would live a lot longer, including, of course, the delay in the involution of the thymus gland. So he gives a lot of references to this. Is this something that you've considered or pondered at least as it relates to what young people could theoretically do if they chose to?
Almost no modern day physicians would um, cooperate with a child of 10 who wanted to take drugs like that. However, there was an experiment done by the Catholic Church in the Middle Ages where they castrated many prepubescent boys to preserve their voices in Catholic choirs. Okay, the castrati. And their biology is pretty amazing. Among other things, they actually tended to be taller than the people around them. Of course, their biology was different in quite a few respects. There are some historical claims that they lived long and healthy lives. Somewhat more tragically, I know of one other body of data that bears on the question of castration in humans and lifespan. And that was an experiment conducted chiefly in the American South, where under the influence of eugenics laws, they castrated felons and put them in indefinite incarceration. And most of the felons that were castrated in the Old South happened to be African Americans. And if you compare the survival patterns of these forcibly castrated individuals, the males tended to live about 10 years longer than
Wow.
similar individuals who were not castrated. And I have often brought up this point in my lectures over the last 40 years. And one of the almost universal reaction in the males of the audience is, "Oh God, no." And a frequent joke that is made in response to this little story is, well, however long you live after castration, it will certainly feel longer. You'd be surprised how often I've heard that exact joke. However, after I made that comment once to a senior citizens later life educational group, a very old man in his 90s came up to me and told me that he had been castrated because of testicular cancer, and that ever since then his health had been quite good. And he felt happy about his castration because he attributed his great longevity and health due to that surgical intervention. So, Bill, I put it to you, whatever the conjectural effects of delaying puberty, you, as a biologically intact male, have a choice you can make right now.
I'm going to put the kitchen knife away for the moment, but the androgen deprivation syndrome that prostate cancer patients encounter when their testosterone is chemically shut down, or even via castration, often it results in unfavorable factors, a lot of bone deterioration, just a lot of adverse effects. So once you have passed puberty and you're an aged person, it seems like suddenly removing the testosterone in men, and certainly with women, a lot of deleterious effects begin to occur.
when you average out all of the positive and deleterious effects together, the average longevity appears to be very substantially enhanced, on the order of a decade. It's the single most powerful biological intervention to increase lifespan that we have good data on. Now, castration is not the same thing as taking a drug that will lower your testosterone level. That's a fundamentally different biological
Right.
intervention because of all
Right.
of the secondary effects of those kinds of drugs, because all drugs have hundreds of effects all through the transcriptome and metabolome.
Understood. No, makes sense. But that is fascinating information that you're disseminating. It leads a lot of scientists then to pursue avenues of research that could literally result in some major advances. You may be aware of what we've been recommending for the last 4 to 5 years for our followers to consider a drug called Metformin, boosts AMPK, suppresses mTOR a bit, and we feel most people should be on that. If you have an opinion on it, feel free to let the group know because most of us are taking it right now.
So I'm very interested in drug research. Full disclosure, I've been a founder and consultant to two different baby pharmas, and I still consult for private sector companies. What I haven't shown in this talk is all the work we have been doing on genomics, transcriptomics, and metabolomics. And the fundamental problem that is now facing all pharmaceutical companies and all supplement companies that wish to retune physiology is that even if you are absolutely correct about the directly observed effect on one or two enzymes of interest, it's now a virtual scientific certainty that you're also affecting hundreds of other enzyme functions, either by altering transcript levels or shifting the balance among metabolome components. So to properly address the value of any particular medication that is taken regularly that does not affect an acute life-threatening condition, you need to look at thousands of transcriptional effects and probably tens of thousands of metabolomic effects, as well as a wide-ranging assay of the functioning of all the organ systems. The idea of truly focal medicational interventions is an idea that died with the advent of genomics about 20 years ago. Basically, we now know enough to know that single or simple pathway models are almost never correct. They're correct less than 5% of the time. Very occasionally, you find a gene product that has extremely focal effects and doesn't connect to dozens to hundreds of other causal pathways physiologically. But that is by far the exception. Overwhelmingly, the rule is that everything is connected to everything else. So even if you get a focal effect that you like, such as a reduced serum glucose level, characteristically, the medications that are prescribed for type 2 diabetes have a host of other effects, many of them adverse, from sarcopenia to cognitive confusion. So I believe that we're on the threshold of systematically evaluating every drug and every supplement that we take from the standpoint of its effects throughout the entire transcriptome, metabolome, and indeed all of the organ systems. And that is a future to which I would like to contribute.
This is a very valid point for virtually every medical or supplemental intervention. What are those kind of off-target effects that are deleterious? What we like about metformin is the consistency of the data, the reduced risk of cancer, the reduced risk of progressing from metabolic syndrome to type 2 diabetes. Just a myriad of benefits. We've listed them going back to 1995 in our various journals, where it seems like the benefits outweigh the risk. I can't wait, of course, until the trial, which finally got approved and funded, as you may know, got about $70 million of funding, and they're going to test metformin by itself, which we don't really advocate because by itself it's not going to give us, we feel, the overall consistent benefits we'd like to see with people who also take care of their health systematically. But we may know in the next 4 to 5 years just how well it really works. And at this point, is there anything that you do recommend for our typical viewer, a typical person? I'm 65 years of age, by the way, and a lot of us are unfortunately older. We're trying to stay alive long enough until your prediction, and we love the prediction you made earlier this year, I think in January, that biological immortality is about 125 years away. Regrettably, we're not going to make it unless we intervene.
Whenever I make a prediction, I err on the side of being conservative.
Thank
And
you.
I should just disclose to you, Bill, you and I are the same age. So, so I totally appreciate your predicament. The number one thing I recommend is vitamin D3. And on the one hand, there's a ton of positive data for it, as there for other supplements, but also its toxicity profile is particularly good. It's fairly hard to overdo it, although I believe some people do overdo it. It's well measured in serum samples. And I think it's one of the most common chronic nutritional deficiencies on a modern diet. You have to eat a lot of salmon, among other things, to nutritionally get enough vitamin D3. So, and on the other hand, you have to spend a lot of time outdoors wearing relatively little clothing below specific latitudes. And, you know, you and I are pretty white, Bill. It's, you know, you and I are not spending enough time out of doors. It's just, I can just look at you and tell that. And I'm guilty of that as well. So you and I definitely need to supplement with vitamin D3. After that, I think I don't make universal supplement recommendations. If there are specific problems that people have, like an overly high serum glucose level, muscle spasms, and other specific symptoms that specific drugs and supplements can address, then by all means. But vitamin D3 is my one universal go-to.
Understood. We've been talking about that for a couple decades. And what's really nice about D3 as opposed to so many other supplements is we can measure the levels rather precisely in the blood. We currently recommend about 40 to 60 nanograms per milliliter, probably being that ideal range. And we do find people sometimes exceeding 100. And what we do is we call them up. We say, stop taking your supplement for a while. It'll stay up there for a while. And then, get another test a couple months later and get it between that 40 and 60 nanogram per milliliter range. And that's probably the optimal place to be from what we know today. So appreciate that insight. And is there anything that you're personally doing that you'd like to relate to our group that we might want to emulate based on your incredible knowledge?
Well, for people over 40, I universally recommend that they transition to a scientifically correct paleo diet. And this is something where we've done a lot of research over the last decade. Some of it's published, some of it isn't. It turns out to be a very general principle that if you're a species that has undergone a major lifestyle change in its recent evolutionary history, I don't mean in the last 2 generations, I mean the last, 100 to 500 generations, then young people are well adapted to that new lifestyle because that's enough time for natural selection to take care of them. But the older you are, the less attention natural selection pays to adapting you to your new lifestyle. And the vast majority of humanity now leads an agricultural to industrial lifestyle as opposed to a hunter-gatherer lifestyle. We lived as hunter-gatherers for at least 1 million years. 1 million years is enough time for natural selection to reach deep, deep into the life cycle, to tune your physiology to that particular diet and that particular pattern of activity. 10 to 20,000 years since the agricultural revolution was certainly enough time for Eurasians to adapt to the consumption, particularly of grass species like rice, oats, barley, wheat, and so on. But that adaptation is going to fade out starting in your 30s. And I think it's fairly negligible by the time people hit 50. And I have talks that you can see on YouTube on this. I say that not my views are not based on verbal concepts. They're based on mathematical reasoning and data, because it's a completely general pattern that arises from the decline in the force of natural selection, that young individuals in any population are adapting really fast to the environment as it changes. And the older you are as an individual in a population, the more you're lagging behind the young people in how well you're adapted to the new environment. And there's a simple way I have of trying to convey this idea, which is that none of us are adapted to a diet of Twinkies and Red Bull, right? The Red Bull, the beverage. It's a completely evolutionarily novel diet. It's those kinds of foods, which are very common in supermarkets and convenience stores, are, the highway to obesity and type 2 diabetes, right? Because evolution by natural selection has not adapted us to that diet. Now, if we were to stay on that diet for the next 300,000 years, we'd be perfectly well adapted to it. It's a diet that contains lots of nutrients. Just nutrients that we're not particularly good at eating year after year. They're nutrients that won't kill you if you are desperate one afternoon, but if they're a regular part of your diet, you have no adaptation to it. So we're not adapted to industrial foods invented in the last 140 years. Another example of those foods, which is not commonly known, is seed oils. People did not consume seed oils dietarily before 1880. It was an invention of American agribusiness, which slowly spread around the world from the 1890s to the 1950s, bringing with it an upsurge in heart disease and cancer. Similarly, high fructose corn syrup, invented in the 1970s, spread around the world over the last 40 years. Another common food ingredient that fosters obesity and diabetes. And indeed, as it is spread around the world, you get obesity and diabetes.
Absolutely. We've talked a lot about that, different presentations. Final question, by the way, is intermittent fasting. A lot of our group is doing it, about 16 hours to 18 hours most days. Some people do it 1 or 2 days a week. Any comments about that as far as your research and knowledge base is concerned?
So we have worked on dietary interventions for more than 30 years. It's quite a lot, I could say, dozens of publications. There's also a lot of interesting human data on this, of course, and you're quite expert in it. But I would say, again, in terms of our evolutionary history, hunter-gatherers don't eat 18 hours a day. They just don't do it. A hunter-gatherer lifestyle involves periods of significant fasting, of significant reduction in nutritional intake. The relentless consumption of calories by modern American individuals of even moderate levels of affluence is an evolutionarily abnormal situation. It's even evolutionarily abnormal by the standards of agricultural lifestyles. Agriculturalists do not get abundant nutrition every day of the year. So I think calling it intermittent fasting or caloric restriction is a misnomer. I think the correct way to think of it is as a reversion to more normal dietary patterns. Okay?
That's
So I'll just tell
fantastic.
you, for myself, I mean, I've practiced intermittent fasting for my entire adult life simply because um, I've generally been unwilling to take the time to spend that much of my life eating.
Very good.
And you know, one of the benefits of that is I've had no problem with weight control um, or, or, uh, or waist circumference, throughout my life. Um, so I guess to me, eating all the time, 7 days a week, is a completely abnormal and artificial lifestyle. And the more you can avoid that, the better off you will be, short of actual acute starvation.
That is a spectacular conclusion, Dr. Rose. And I just hope your inspirational words and your incredible experience, your lifetime uh, calorie reduction, normalizing diet, in other words, fantastic. Hopefully, it will inspire more of our supporters to emulate that.
Thank you, Bill.